Second unit, properties of solids. What is the force of friction? Why it is difficult to walk on the wet marble floor. So force of friction is a contact force. Friction is the force that resists motion when the surface of one object. Example, force of friction between two stones rubbed with each other on a wet marble floor. The friction is very less because marble floor has irregularities that get filled with water. We can walk only when there is more friction. Due to the less friction, we may slip. So it is very difficult to walk on a wet marble floor. Advantages of friction. The advantages. Friction help us to walk, turn and stop. Friction help us to wear caps and rings. Friction help us in the transfer of energy. Friction help us in making fire. Friction help us to hold on to objects. Disadvantages. Produces unwanted heat. Reduces efficiency of machines. Eco hazard. Produces unwanted noise. Causes wear and tear. Define density and writes its formula. So density, mass of a unit volume of a material substance. The formula for density is D equal m by v, where D is density, m is mass and v is volume. Density is commonly expressed in units of gram per cubic centimeter. For example, the density of water is 1 gram per cubic centimeter and earth density is 5.51 gram per cubic centimeter. Formula explain with example. So drag force formula. In commonly used contexts, drag force is the force that is exerted on a solid body moving with respect to a flood due to the movement of the flood. For example, drag on a ship moving in water or drag on the plane moving in the air. Therefore, a drag force is the resistance force caused by the motion of a body through a fluid like water or air. This drag force acts opposite to the direction of the oncoming flow velocity. Therefore, this is the relative velocity between the body and the fluid. Define pressure and gives its SI unit. Pressure is defined as the thrust, perpendicular force on a surface, acting per unit area of a body. Mathematically, it can be defined as pressure equal force upon area. SI unit of pressure is Pascal. 1 Pascal is the pressure exerted by a force of 1 Newton over an area of 1 meter square. Also, 1 Pascal equal 1 Newton upon meter square. Define Pascal law and its hydraulic lift principle is the diagram. So, Pascal principle, also called Pascal law, in fluid, gas or liquid mechanism state that in a fluid at rest in a closed container, a pressure change in one part is transmitted without loss to every portion of the fluid and to the walls of the container. The principle was first enunciated by the French scientist Blaise Pascal. Pressure is equal to the force divided by the area on which it acts according to Pascal principle. On a piston produces an equal increases in pressure on another piston in the system. If the second piston has an area 10 times of the first, the force on the second piston is 10 times greater, though the pressure is the same as that of the first piston. This effect is exemplified by the hydraulic press based on Pascal principle, which is used in such application as hydraulic brakes. Pascal law discovered that the pressure at a point in a fluid at rest is the same in all directions. The pressure would be the same on all planes passing through a specific point. This fact is also known as Pascal law or principle. Pressure at a point in a fluid is equal in all directions. 1 lb pressure applied to small piston 1 SQN, 100 SQN pressure transmitted by liquid 100 lb. Hydraulic press. A multiplication of force can be achieved by the application of fluid pressure according to Pascal principle, which for the two piston implies P1 equal P2. This allows the lifting of a heavy load with a small force, as in an auto hydraulic lift. But of course, there can be no multiplication of work, So in an ideal case with no frictional loss, W input equal W output. Input force P1 equal F1 upon A1 D1 D2. Flood F2 equal output force. So F2 equal A2 upon A1 into F1. Multiplication of force. So P2 equal F2 upon A2. F1 into D1 equal F2 equal D2. So D1 equal F2 upon F1 into D2 equal A2 upon A1 into D2. You have to pay for the multiplied output force by exerting the smaller input force through a larger distance. Define Newton's law of viscosity with example. It states that the shear stress in a flowing fluid is directly proportional to the rate of shear strain. Mathematically, shear stress proportional du upon dy, इसलिए shear stress equal u into du upon dy, where u viscosity, dynamic viscosity, rate of shear strain. Significance. The floods which followed Newton's law of viscosity are called Newtonian floods. Quicksands, corn flour with water, and putty are examples of dilatant floods. Pseudofloods. The viscosity of these floods decreases when shear stress is applied. These floods are the opposite of dilatant floods. Ketchup is an example of pseudoplastic. Why does free surface of liquid behaves like its stretched membrane? So, when a liquid is exposed to the air, it behaves like a stretched membrane as the water molecules are attracted to each other. This property of liquid is also called surface tension. Surface tension is defined as the property of liquids to behave elastically, which makes it to acquire the least surface area that is exposed to the surface of the atmosphere as possible. At liquid air interfaces water molecules to each other, which is a cohesive force, then to the molecules in the air, which is an adhesive repulsive force. The combined effects of these two forces in an inward force at the surface of the liquid, which cause the surface to behave as if it were covered with a stretched elastic membrane. So the phenomenon due to which the exposed liquid behave like a stretched membrane is called surface tension. Tube, whereas mercury falls in the same tube. Explain. The level of mercury fall. The mercury has higher cohesive force compared to adhesive force. Therefore, the molecules of mercury are more attracted towards its own molecules than the capillary walls. So the level of mercury will fall. Size is given by h equal to t cos theta upon rpg. H height of capillary, t surface tension, theta angle of contact, r radius of capillary, p density of liquid, g acceleration due to gravity. For mercury, glass surface theta is obtuse, hence cos theta is negative, hence h is negative, hence mercury will depress below the level of surrounding liquid.